Hello student, today I am going to explain to you how to find the polar equation of the conic. That is, how to find equation of the conics means the hyperbola, the parabola and the ellipse. So what will be the general equation of those conic in polar form? So now here in polar form we take P to be any point of the conic having the coordinate as r theta, where r here by taking S to be the focus and the line which passes through the focus and the line joining the focus to the corresponding vertex as the initial line. That means this line as the initial line. S is a focus which will be considered as the pole. So if I take theta to be the angle made by this line PS with respect to the initial line, and R is the length from this point from S to P, then the coordinate of P will be r theta in polar form. So now here, let us find what will be the equation of the conic in polar form. So now take point P having the polar coordinate as r theta to be a point on the conic. Now join PS, this one where the length PS is equal to r. Now consider this angle PSX to be theta. Now we draw PM perpendicular to the directrix. Directrix means a fixed straight line. And then next you take P1 to be a point again, another point on the conic where this P1S is perpendicular to the initial line. So this P1S will be, if I extend it to this one, then this P1S up to this P1 prime here will be called as the latus rectum because it is a focal chord which is perpendicular to the x-axis or the initial line. And since P1S1 is half of that, so that this P1S will be called as the semi-latus rectum. Latus rectum is nothing but it is a focal chord which passes through the focus and perpendicular to the x-axis or the initial line or the axis of the conic. So now here, let me take this P1S to be equal to L. Now by definition of conic, PS, this one, PS is equal to E times of its perpendicular distance from the directrix, E times of PM. But what is PM is same as NX because I draw a perpendicular from P to draw a perpendicular PN to the initial line or the x-axis. So this implies that PS is equal to E times of NX. But NX can be divided into NS plus SX. So you can write this one, PS is equal to E times of NS plus SX. This is called E times of NS plus E times of SX. What is SX? SX is same as P1 M1. So this is equal to E times of NS plus E times of P1 M1. Now P1 M1, see, P1 is a point on the conic whose distance which is perpendicular to the where PS is perpendicular to the initial line. That means the distance from this point P1 from S will be the distance of a point P1 of the conic from the focus, and P1 M1 is perpendicular distance from the directrix. So by the definition of the conic, P1 S is equal to E times of P1 M1. So from the figure, P1S will be equal to E times of M1. So now this E times of P1 M1 has to be replaced by P1S. P1S. But what is P1S? I have taken P1S to be the semi-latus rectum. So if I take the length from here to here to be L, so P1S is equal to L. So this is called E times of NS plus L. Now let us find NS. Now if theta is the angle from here to here, then the angle from this side will be pi minus theta. Now you can see from here that this PNS is a right angle triangle where the angle from here to here is pi minus theta. So what is NS? NS is represent the base and R here PS represent the hypotenuse. So NS will be R times of cos pi minus theta. So NS has to be E times R of cos pi minus theta. So you can see from it is like this. This is pi minus theta. This is P, this is N, this is S. So NS, as we know that cos of pi minus theta is equal to base, that is ns by hypotenuse, that is ps. Ps is equal to r, so it will be ns by r. So ns will be r times of cos pi minus theta. So therefore you can replace this ns by r times of cos pi minus theta, then plus with that l here. So this will be equal to, what is cos of pi minus theta? It is minus cos theta. So this is equal to minus e r cos theta plus l. Now ps, since ps are taken to be r, so on this side you replace it by r. So r will be equal to minus e r cos theta plus l. So this implies that transfer this one to this side, r plus e r cos theta equal to l, or r into 1 plus e cos theta is equal to l, or 1 plus e cos theta is equal to l by r. So this one is the required equation of the conic in polar form, that is in terms of the polar coordinate. Therefore the equation of the conic, that can it can be the equation of the hyperbola, the parabola, or the ellipse, depending on if e is greater than 1, it will represent the hyperbola. If e is equal to 1, it will represent the parabola. And if e is less than 1, then it will give you the polar equation of the ellipse. So this is how we calculate the polar equation of the conic. Now next, let us find what will be the equation of the directrix of the conic. So for this one, we can calculate it in this way. Equation of the conic, the equation of the directrix of the conic. So we first of all, let us draw this figure. It's like this. So let us take this S to be the focus. L prime here is a latus rectum. That means a focal chord which is perpendicular to the initial line, that is the x-axis. If I take the length from here to here, SL is equal to L, and then take this directrix here. So I need to find what will be the equation of this. This is the directrix. So I need to find what will be the equation of this directrix in polar coordinate. So from here you drop a perpendicular to this one at K. Now next, from this S, draw a line like this which is meet the directrix at P. Let this angle be theta. Now let SP is equal to R. This is P here. Now this is the vertex and this is Z. So take P to be any point on the directrix, where the polar coordinate of this P is R theta. That means the length from P to S is equal to R, and PS makes an angle theta with respect to the initial line or the x-axis. This is the initial line or the x-axis. So the coordinate or polar coordinate of this point P on the directrix will be R theta. Now let us see what is this one. What is the S set? Now you can see that from here that SP set is a right angle triangle at this one, at set. Now if this is theta, so what is S set? S set represents the base, and the base is equal to hypotenuse into cos of theta. So you have from the figure S set is equal to SP cos theta, but SP is equal to R. So this implies that S set is equal to R cos theta. Let us name this as equation 1. Now what is LS? SL is the semi-latus rectum. And if I take SL is equal to small l, the length from here to here, then in that case S capital L will be equal to L, the semi-latus rectum. Now see this one. This L here is a point on the conic. By definition of the conic, what is SL? SL is called E times of LK, where LK is a perpendicular distance from L to the directrix, and SL is the distance of this point L from the conic to the focus. This is a focus. So by definition of the conic, by definition of a conic, SL is equal to E times of LK. But what is SL? It is equal to L. So this implies that small l is equal to E times of LK. Now what is LK from the figure again? LK is same as S set. So you can replace that one. So this implies that L is equal to E times, in place of LK, you can replace it by S set. So now this gives you what? L by E is equal to S set, equation 2. Now from 1 we have S set is equal to R cos theta. From 2 we have S set is equal to L by E. So on comparing this 1 and 2, you will get that L by E is equal to R cos theta. And this is the required equation of the directrix in polar form. So hope it is clear now. If how to find the equation of the directrix of the conic in polar form. It is given by the equation L by E is equal to R cos theta. So this is how we calculate that L by E is equal to R cos theta as the equation of the directrix.